Hey, right.
This right here is a little
Keep it, it's okay.
thing that I put together from some stuff I gathered on service and safety systems, and giving you an idea of what's out there on there and what you've got to do when you're working on stuff that has safety systems on it, where you can make it a better job, and you know what to kind of watch for and all that. We'll be talking about this stuff. The Dod User Services categories, I know we got rear end collision warning, right? Roadway departure warning, lane change, merge collision warning, you know, whenever somebody's about to run into the side of you. Railroad crossing collision warning, and vision enhancement, location specific warning, all of that stuff. That's the Department of Transportation directly contributing to vehicle safety, and then safety impacting would be navigation and routing, real-time traffic information, driver comfort and convenience. This has got the potential to distract the driver. You know, when you're looking at your GPS, when you should be looking at the road, or when you're looking at anything, when you should be looking at the road. This is higher tech stuff, and you might notice the way that this thing is laid out. During routine service procedures, if you're not careful, you can damage some of this stuff just because of the way it's out there. Okay, so here's your environment, your traffic, and there's interference with it. Your communication system, you got a sensor, your processing signals, human-machine interface, you know what that is. That's the thing on the dash. That's where you look at the screen and all this kind of thing. Then you got actuators and vehicle actuators is what it does, you know, to help you if it applies the brakes, or if it applies the brakes on one side when you're in a curve, like the stability control and all that. Vehicle dynamics is all part of that. And there's your operator. See, your operator's way out here. And so, anyway, they got a computer control input and output, and there's not much maintenance or service required usually. They don't hardly ever have to do much of anything to these to keep them going. I mean, it's kind of like, it's vaguely like the video surveillance system, you know, that I installed in our house over there. I don't have to hardly ever do anything to it. You know, it just runs like that. Collision avoidance and stability control are two of the many. Like if you got this stability control off, you know, you're liable to overshoot a curve, you know, but if you got stability control on, you'll go. And this right here does not mean that the sign is telling you that you need to do a burnout, okay? All right, on a curving road, a forward-looking sensor needs to have a wide field of view. It says vehicle position needs to be combined with road geometry to know whether the lead vehicle is in your lane, another lane, or on the shoulder. You're going on a curve over there. Now, have you ever been going around a curve and another car was coming around the curve the other way a little too fast, and you thought he was going to get over on your side? You know, that's pretty spooky. And it has, sometimes cars hit in situations like that. It's a really nasty thing. Typical radius is 300 meters, which is about 1,000 feet. And typical look ahead, you only get about 100 meters that way, which is roughly 100 yards, a little over 100 yards. All right, there's targets and clutter. Other things in the field of view can include all these signs, parked cars, overpasses, guardrails. That's in the radar literature, it's called clutter. Adaptive cruise control, only concerned with moving vehicles, can reject any stopped object as clutter. Like with adaptive cruise control, you know what that is. When you're coming up behind a car and you're going a little faster than they are, it sees that car up there and it sets your speed to match the one in front of you. You know, it does it kind of automatically. Rear end collision warning system need to sense stopped vehicles. And so they need high acuity sensing of vehicles and lanes to separate targets and other vehicles from clutter. So they need to know what's stopped and what's going. Just because it sees a car doesn't mean the car's moving. It needs to be able to tell whether it's moving or not. And so you can buy this add-on system on Google for $649 and put it on any vehicle. What that thing is right there. The camera and the processing software watch and respond to road service markings when turn signals are not engaged. If you turn on the turn signals, it doesn't fuss at you for changing lanes. But if you don't have your turn signal on, it's assuming that you're supposed to be in the middle of the lane. So the car automatically corrects course if it reaches lane markings and a higher level of keep assist. Sometimes it'll actually bounce the steering wheel. You know how it kind of like when you roll these little rumble things over here? Even if they're not there, if they get those lane markings and it's warning you, hey, you need to, you know, get back in line and all that. The corrections are subtle. The driver can always override the car and turn the wheel manually if they, you know, if they want to. Hear about those people that hacked into that? They set it up to see if they could do it. And they hacked into this Jeep and drove it off, you know, and him driving it, they took the control of the car away from him and drove it off the road. You know, it didn't do anything dangerous, but they did that with a laptop sitting in their house. They managed to link to the vehicle and do it. I mean, that's where we are now, okay? All right, these passive warning systems use lane markings as the basis for their calculation, but they're only as good as the road markings, and they can malfunction when the markings aren't clear. Rain, snow, dirt, you know, anything that gets over those things. Some customers will shut it off because they get tired of this. You know, you can turn that stuff off if it's bothering you. Okay, radar is a really good choice for seeing big metal objects through fog. So the frequency is 77 gigahertz. A radar works at the speed of light, so sensing is almost instantaneous. And we're going to talk a little bit later about a platoon. Now, what's a platoon have with the cars? I'll tell you in just a minute. More sophisticated versions sweep the beam mechanically or use 2 or more beams to measure bearing and range. Do you know how the Patriot missile batteries work? How they can used to, if you had a low frequency AM receiver, which is what they put in the cockpits of the jets in Vietnam War, if you were being painted by radar, you'd hear all that squawking. I mean, that, you know,
oh my God, it's
the way you'd hear like a muffle, like radio, you know, interference, and you'd know you're being painted by radar and all that. And of course, there's ways you could dodge it if you were good enough pilot, you know. But anyway, the simple fact was with the phased array radar that they have on these Patriot missiles, it just takes pictures all over the sky all the time. And when it sees something, it just flashes it for a second, then it checks it again, That guy don't even know he's being flashed until boom, you know, take him out. I mean, it can also do that with incoming missiles, not just, you know, piloted planes and all that stuff. A typical resolution, the closest object can be distinguished, is like 1 meter in range, 3 degrees in bearing, you know, and basically talking about the angle of it. Okay, this is what it looks like. This is very interesting to me. This is the picture, and this is what the radar sees. You see that? Isn't that pretty interesting? Now you notice this is reversed from that. And so basically the radar data, horizontal and bearing, you know, you can look at that. I don't go spend too much time on that, but this has been out there a long time. Now this may be an older one. The newer ones may look a little different from that, but it was very interesting to me how this thing is laid out different. You know, you can look at all that stuff. Okay. LiDAR, and laser rangefinder, this is a different kind of thing. They refer to measuring distance using the travel time of a laser beam, which is what I got here. The laser can be scanned over the scene with mirrors and make a range image. They can be focused in little small spots, fractions of a degree. They got a lot better resolution than the radar. Instead of sensing a blob, the LiDAR can make a lot of measurements, and the scans measure fine details of shape. And so it can be blocked, though, by the same kinds of effects that impede human vision, which would be fog, snow, heavy rain. Okay, now what we're looking at here, this is a picture. I'm going to show you a picture. And the top picture shows reflectance data. That's the amount of laser energy returned from that point on the scene. The lower picture shows range data, brightness encodes range. This is what it looks like. That's pretty doggone precise, isn't it? What you're seeing right there. But it's looking at both of those. It can make all kinds of really cool decisions and all that. So sonar works by measuring the travel time of sound. And sound is really weird. You know, I was telling them guys yesterday that some of the sonar type mass airflow sensors actually have got a speaker and a receiver, and when air blows through there, it blows the sound. You know, you can blow sound and all that. And did you ever, in the Civil War, they used to have these silent battles when people wouldn't even know there was a big battle going on the other side of this mountain. And they would go up there and they'd just be totally quiet. They wouldn't hear anything. And then when you come up there and you look over that mountain, because of the dynamics of the atmosphere and all that kind of stuff, you would see a big battle going on there and you wouldn't hear a single shot or anything. It looked like you were watching it without sound. It was a strange thing, you know. You can look that up, it's really cool. Anyway, sonar hardware doesn't cost very much, right? And sound travels kind of slowly through air. What's the speed of sound, anybody know about?
Less than the speed of light.
Well, yeah. That goes without saying. How long? You know? Usually if somebody shoots at you and you're a long way off, the bullet goes by before you ever hear the shot. Because the bullet goes faster than the sound of it, right? But it's usually about 740 miles an hour or something like that. And so anyway, they're commercially available for blind spot sensors and backup warning sensors. Now this is funny to me. State departments of transportation have to clean up construction debris, fuel spills, car parts, tire carcasses, and so forth. I've seen stuff laying in the road. Good grief, what was that back there? You know, or you dodge it because you find it's a big piece of metal to tear your car up. That one girl ran over a piece of rebar in the road, knocked his aim put a motor in that Cobalt, you know, because she ran over something in the road, knocked the holder oil pan, all that kind of stuff. Now, State Highway Patrol will get reports of washing machines, home appliances, ladders, pallets, deer, you know. Bill's litter retrieval machines, 85 million pieces of litter a week are picked up by these litter retrieval machines. And why don't somebody throw stuff out the window? You know, that's just ridiculous. Rural states report 35% of all rural crashes involve animals, mostly deer, but they moose and elk and farm animals. If you hit a hog, it's like hitting a rock in the road, man. Just stops your car, just tears it all up.
You hit a horse, it's like hitting a rock.
Yeah, hitting a horse like he comes in the car with you, you know. Non-scientific survey indicates people have hit tire carcasses, mufflers, deer, dogs, and even a toilet. LiDAR is useful for seeing small objects. See, so if your car sees these objects in the road, it can kind of take evasive action and keep you from having trouble there. Okay, so the variants to use a reflectance channel of radar or LiDAR and look for bright light return, which is probably come from objects sticking up out of the roadway, like that. Sonar got insufficient range. Advanced radar and stereo video systems may work. Now this is what the stereo, the rise of the machine. See, you got these two right here, stereo work. And so, let me go to that next slide. Here's a tree, and here's how this thing shoots, right? You know, the radar that the only cop cars that they used to use, and I'm sure they got a whole lot more sophisticated stuff now, used to would have a little grid in there, and it would take pictures of your car repeatedly, and how many more squares in that grid it filled up, it could tell how fast you were going, and all that. But this thing right here, the camera gives a 3D location of the object, and this is kind of what it looks like here. Low resolution stereo for detection and requisition of nearby objects, side looking sensors on a bus. There's your original image. The center is the depth map from stereo, and the brighter is close. Blobs of pixels at the same distance, you know. The overlays show detected objects, two pedestrians, and a car. You can see the stuff over there. It doesn't really need to know what it is. It needs to know there's something there, and whether it's moving or not, how far away it is, and all that. All right, so now right here is you got long range stereo. This is a picture. It's basically that's what it sees, and this is what you see. See, and it sees stuff in the road. It can even see a dip in the road and all that. And it can say objects on the road are 15 centimeters tall at a range of 100 meters from the camera, and it can spot them out there. See, and besides the obstacles, it's found the person, the sign, the grass along the road. See, it's picked up on all that stuff. All right, so recognizing lanes, though, is necessary for automated guidance and lane departure. It's important for rear-end collision warning to know which lane you're in and which lane the other vehicles are in, naturally. And they put magnets in the road. University of California, Berkeley's been talking about doing this, and they see how they drill a hole, and they put these cheap magnets in the road. And they got it set up so these magnetometers underneath the front of the rear bumpers, that's sort of like the thing they use for airport security, you know, you walk through it and it sees metal. They pick up the magnetic fields for input across these little magnets. So they can be polarized one way or another to provide binary code for map location purposes. You know, you can see that. That's pretty neat stuff, and that's kind of how it works down there. Placing magnets in lane margin stripes, they're not affected by, magnets aren't affected by snow and ice. It can see the magnets in them through that. So this radar can be used with lateral control, modified lane marking tape, frequency dependent tape properties, can provide distance and other information. You can kind of see how that works right there too. All right, typical vision-oriented system for lane tracking works this way. You can see the little blue dots, you know, that's the side lane. Then they got for the dotted line, they got a different one over here. And this is basically demonstrating how how it can see things and the decisions it makes. These self-driving cars use technology like this. Well, how to tell what the surface condition is. You ever seen black ice?
Yeah, not much around here.
You will not see it until you're on it. Usually. And it don't matter how good your tires are, if you don't have snow chains on them, you're going to go somewhere, man. And I actually was, we was driving one time, me and this buddy of mine took a trip out to north central Texas, where I was born, and we were coming down Interstate 45 toward Houston, and it was really, really, really cold. It was in January, it was in wintertime, and there was ice this thick on the side of the cars, because it was that cold. And when we would go over these bridges, you know, little small bridges and all, that bridge, the ice was on that bridge. You couldn't tell that there was ice on there, but if you turned the wheel just a little bit when you were going on that bridge, you'd just go all crazy, you know. I mean, even on a straight road, there was cars that had gone off in the ditch because of it, that you could see going past the bridge. And that's pretty doggone spooky. And then you got this dangerous crosswinds up in the Texas Panhandle where there's these 40, 50 mile an hour winds blowing across the road. Okay, so you come up beside this 18-wheeler, right? He's blocking the wind off of you, and all of a sudden you've been fighting the wind. Now you're correct, but whenever, well, you've actually been fighting the wind, and then all of a sudden he blocks the wind, and you almost drive under the truck. You know, because that's just pretty scary too. Well, you use infrared spectral photometers are used to detect differences between ice, water, dry pavement. Microphones in the wheel wells listening for splash. This is trying out what the surface of the road like. Roadside mini weather stations with sensors built into the pavement. Careful instrumentation of all the wheels of a car looking for incipient slip on the driving wheels. All right, so system level condition. Now this is a platoon. See that? What they do is they set it up so the cars are all traveling pretty close together, so if somebody does have a crash, they ain't moving very far before they run into one another. So it's not like you got a lot of momentum built up before you crash in. See, that's a California thing right there. All right. Now, assessing the driver's alertness in a drowsy driver warning system. This stuff is in cars. You're gonna be, working on cars that have it. The more time that goes by and the more work you do on the newer cars, the more you're gonna be dealing with this stuff. That's why I'm giving it all to you right now. Alertness can be sensed indirectly by watching lane keeping performance, or if you're weaving, or directly by watching for eye blink rate of closure. See this guy's eyes? See, he's got his eyes closed. And the dash, the camera in the dash is watching. And it sees you close your eyes and it turns on the coffee cup. You kind of knew about that, didn't you? Boom, coffee cup pops on. You got a car, your folks got a car that does that? It illuminates the face with 2-hour wavelengths, one of which reflects from the retina on his eyes, and subtracting the images will create a blank image if the eyes are closed, or an image with 2 bright spots if the eyes are open. See, he's closed his eyes, so you're not even seeing his retinas anymore, and it knows this guy's getting sleepy,
They said Charger does that.
Yeah, but all right, if you're going to be working on this stuff, so all the others that come with it got to be regarded carefully during your routine service operation. So when you're working on this stuff, you got to be thinking about it. You got to keep track of the new systems as they emerge and avoid mistakes. Sometimes we would get cars in there that have new stuff in them, and if you didn't know what was on there, a lot of times, most of your new product information will come out in little. Probably they'll have you looking at them online. They'll have stuff that you're required to look at. And we used to actually go to schools that would have new product info on the brand new stuff that's coming out, so we'd be up to snuff on it. However, the manufacturer does it wherever you happen to be working. You need to be aware of what's coming out so you'll be abreast of all that stuff. Do enough research to be knowledgeable on the ones you work on. You can be stress-free at the end of the day. That's a good thing, isn't it? Although I don't know how we're going to be at the end of this day. We may not be stress-free. Understand what kind of systems used. Use OE quality glass for window repairs and windshield repairs. Watch out for accessory that blocks the sensors or cameras. People hang stuff on there where they can't see, and they think about this. You're used to this thing telling you when somebody's in your blind spot. Now, I'll tell you what happened. That I knew for good and doggone well, you can just backtrack. You couldn't swear to this in a court of law, but you can kind of figure it out. This lady's driving along between Dothan and over there somewhere, and she was driving on this road. Have you ever had anybody just ride in your blind spot? Have you ever rode in somebody's blind spot? You don't even think about it, but you're real comfortable because you can see them all the time. But they can't see you, and all of a sudden they start to change lanes, and you go, hey, idiot, honk, you honk. Well, they couldn't see you, man. They look in the mirror, they don't see you. They look in this mirror, they don't see you. They don't see you over here because you're just in exactly the right spot. Well, see, that's why a lot of these things, they say a lot of times it's driver error if somebody doesn't know what's back there. So they actually tell this thing, well, let's say, what if you've put something on there some kind of way that blocks that, and they're accustomed to it, and then they move over, run into somebody, and they say, well, it didn't tell me they were over there. In a way that's kind of dumbing us down, like the cars that park themselves. The parallel park, I mean, we used to have parallel park when we took our driving test. They put a place where you had to parallel park, even if it had cones or whatever. You'd have to back in there and show the cop that was giving you the driving test, you knew how to parallel park. And that's just, now you just push a button in it or whatever, and it uses all these sensors and parallel parks, Keep tire sizes and pressures to manufacturer specs. Mind the brakes and brake switches. And these things are really important. And a lot of times your brake pedal will have more than one switch on it. Make sure you know which switch does what, and be prepared to do it. If the system components need to be removed or disconnected, make sure the system won't need to be recalibrated or adjusted somehow, because sometimes it will. You know, like even a simple radios on Hondas that say code when you pull a battery off. There's other things that have to be done too. Safety systems don't need to be modified or improved by us. I talked about that before. Airbags, cruise control, any of the safety stuff. Don't say, well, I can make this a little better than it was designed by changing this. Well, if you change this and something happens, you're in hot water. You know, if they, come along here and find out somebody modified the wire and who was the last person that worked on it, oh, he worked on it over here and all that, then they come over here and ask you if you modified the wire, particularly if you wrote it on the work order, so on and so forth. Always put the system back the way you found it, wire for connector for connector, and bracket for bracket, unless you're guided by a recall or a TSB that says do this and change that. All right, most lane departure warning and lane keep assist systems, this is right there above the mirror. It's got a couple of cameras up here, and at the top center of the windshield. And the light's got to be able to reach that camera. So if you use some other kind of glass or something like some window tint on there, it's liable to mess it up, right? Window tint's a dirty windshield. Even if the windshield's really dirty. You ever been driving into the sun with a dirty windshield, couldn't see? That's scary, I mean, I almost ran over a flagman one time out there that was, waving people by because I couldn't see him because the windshield was dirty. I was driving a company truck, though. I don't let my windshield get that dirty, okay? All right. When some vehicles are fitted with radar-based inputs, the sensing unit mounted in the front of the vehicle, usually in the front bumper or grill area, always consult service information to be sure where it's at, okay? Now, it's a nice touch to clean dirt, bugs, or grime from a sensor so that the system operates as reliably as possible. It's a little thing, but it's a professional touch. I used to clean the steering wheel and all. They gave us this Malco upholstery cleaner, and I'd wipe the steering wheel down and just make it all, clean everything up real good, make it cleaner than when it came in. Collision avoidance systems, changing anything that affects ride height, braking, steering, or lighting can affect collision avoidance system operation. You need to know if it's got CAS on it. Always consult your service information to be sure. Make sure tire pressures and sizes follow manufacturer recommendations and shouldn't vary from side to side. And Zane, you might have heard him talking about this at Firestone. If you've got a properly sized tire on one side and a half-inch smaller tire down there on one side, they wear funny. If it's just a tiny bit smaller, it can make it wear unevenly because the tires aren't the same size. But any wheel or suspension modifications, including putting that stupid donut on there. I hate them things. Don't you hate them donuts? All right. Now, a temporary spare tire can impact system operation. Now, as with collision avoidance systems, brake problems, such as grabbing or pulling, if you got brake trouble, it's going to affect these systems. So you got to pay attention to all that too. Make sure everything operates smooth. You're going to do that anyway. Okay, if you install heavy accessories on the vehicle or haul something, load a heavy cargo, that can cause problems.
I can handle it.
Yeah, I like that. That's a true story right there. All right. Active cruise control systems can use radar or a laser-based system to maintain a set distance behind the vehicle. Now listen to this. Lexus service information cautions that it's hazardous to be within 7.9 inches of the vehicle's radio frequency aperture when it's active. You know what I mean? You're standing there, and you're standing really close to it, and it can cause you some issues, give you cancer. You could wind up sterile. You know what I mean? And that doesn't mean germ-free either. Exactly. Be careful. I mean, I'm telling you. Now this right here is the bottom of the mirror. Blind spot detection system sensors are located on the bottom side mirrors. You can see how that would get mud splattered on it, couldn't you? But who's going to look under the mirror? Usually all of a sudden there's a puddle light, if anything. But if you know it's got that, it's not a bad idea to feel under that mirror and see if there's anything, if it's covered up with mud or something, just, wash it off. That keeps people safe, Nice touch to clean these during service. They don't work right when they're dirty. All right, so find out where the cameras and the components are to avoid damaging them during service. Transferring equipment from an old work van to a new one can block cameras. If the old work van had these panels and stuff on the outside for hauling glass and windshield and all that kind of stuff, and you move it to the new van and all of a sudden you block their cameras and that stuff doesn't work right, got to be careful about that. Some cameras are in the grill, so when you're working up in the front of it, fooling with a radiator or something, don't mess the dadgum camera up. Be careful what's up there. All right, so check the basics. Ensure tire sizes and pressures are in spec. Make sure sensors are clean, the lights work. Brakes and steering system need to operate without problems like always, but it's more important than ever. Release system. Use good parts and OEM quality glass. Don't just throw any piece of glass in there because you ate. You know what I'm saying? And that's the end of the joke. Okay, who learned something that they didn't know?
I think we need a question.
I see all them hands going up, huh?
It's gonna take me a while to get the